This is not just any arithmetic progression question. This appeared in JEE Mains 2025. Can you find the number of terms when alternate terms sum to a multiple of the first term and the total sum is 0? Let us solve this smartly in under 2 minutes. First, let me read the question. Let n be the number of terms of an arithmetic progression such that sum k equals 1 to 12 of a 2k minus 1 is equal to minus 72 by 5 a1. That is, a1 is first term here and a1 is not equal to 0. If sum k equals 1 to n of ak is equal to 0, then n is, we have four options. Let us take the first term a1. That is, when you put k is equal to 1, we get a1, which is the first term. We will take it as a, and let us consider the common difference as d. Let us consider the given expression, that is sum k equals 1 to 12 of a2k minus 1 is equal to minus 72 by 5 a, where a1 is not equal to 0. Now let us expand this series by putting k equals 1 to 12. Therefore, we get a1 plus a3 plus a5 so on, a23 is equal to minus 72 by 5 a. That is, when you put k equals 1, we get a2 minus 1, which is a1. When you put k is equal to 2 here, a4 minus 1 is a3 and so on. When we put k is equal to 12, we get a24 minus 1, which is nothing but a23. And in the right hand side, we have minus 72 by 5 into a as it is. Now we have taken a1 as a. Therefore, let me substitute for a1, which is a here, and you can observe this is a3. a3 is the third term of an arithmetic progression, which is given by a plus 2d. Similarly, a5 is a plus 4d and a23 is nothing but a plus 22d, which is equal to minus 72 by 5 into a. Clearly, this left hand side is an arithmetic progression with common difference 2d. Here we have 4d minus 2d is 2d and 2d minus 0 here. A plus 0 is the first term. So that is why this is clearly an arithmetic progression with common difference 2d and first term as a. Therefore, the sigma, that is sum k equals 1 to 12 of a 2k minus 1 is an arithmetic progression with common difference as 2d. Now let us apply the standard formula. When the first term is a and the common difference is d, then sum to n terms is given by n by 2 into 2a plus n minus 1 into d. Here n is 12. Therefore, this left hand side becomes 12 by 2, that is n by 2. In the formula n by 2 we have, so we have 12 by 2 into 2a. Here in the formula we have 2a, 2 into first term. Here also first term is a, so we have 2a plus n minus 1 into d. N minus 1 is 12 minus 1, which is 11, and common difference, d means common difference. In this series, common difference is 2d. That is why we are writing 11 into 2d here. Now let us simplify this by multiplying the terms in the bracket by 12 by 2. So when we multiply by 12 by 2, we have 12 by 2 into 2a, which is 12a here. And right hand side minus 72 by 5a as it is. When we multiply by 12 by 2 into 2a, we will get 12a plus 12 by 2 into 11 into 2d is nothing but 132. That is 2 is eliminated and 11 into 12 is 132 into d, which is equal to minus 72 by 5 into j. Now let us simplify this further. Let us multiply the whole equation by 5 so that 5 in the denominator of the right hand side will be eliminated. That implies 5 into 12a plus 132d is equal to minus 72a. So multiply the terms inside the bracket by 5 so that we get 60a plus 660D is equal to minus 72A. Now carry this minus 72A to left hand side so that we get 132A plus 660D is equal to 0. Let us divide this term by 132 so that we get A plus 5D is equal to 0, which implies A is equal to minus 5D. It is also given that sum from k equals 1 to n of ak is equal to 0. This implies sum to n terms of an arithmetic progression from k equals 1 to n is 0. So again we are applying the same formula, standard formula, n by 2 into 2a plus n minus 1 into d is equal to 0. Now let us put a is equal to minus 5d in this expression. Here in place of a, let us put minus 5d. That implies n into minus 10d plus nd minus d is equal to 0. Because this here I have n by 2, on the right hand side I have 0, so that I can take n into minus 10d plus n minus 1 into d I have. So I am multiplying by d, nd minus d is equal to 0. This implies that nd into n minus 11 is equal to 0. That is, when you take d common here, I will get n into d. N is outside the bracket. When you take d common from the bracket, I will get n into d. Here I have n plus n and minus 10 and minus 1, which is minus 11 here. So nd into n minus 11 is equal to 0. So this implies that n is equal to 11. So that is what was required. So among the given option, the right choice is option D, which is 11. So here we have been asked to find the n. So we got n as 11. If you found this JEE Mains 2025 question insightful, don't forget to like, share and subscribe. Comment below if you solved it faster or if you want more such smart AP questions. Hit the bell icon for regular updates on JEE, KSET and PU Maths tricks.